Simplifying exponential expressions by Drew lines. So for our first formula, we have a times b to the power of t. And our equation is 7 times 4 to the power of 5t plus 2. We're going to simplify 4 to the power of 5t plus 2 with the property of a to the power of b times a times the power of c is equal to a to the power of b plus c. After that, we could turn 4 to the power of 5t plus 2 into 4 to the power of t times 4 to the power of 2. After that, our equation now turns into 7 times 4 to the power of 5t times 4 to the power of 2. We can go ahead and now simplify 4 to the power of 5t using the property of 4 to the power of b times c. It's equivalent to a to the power of b raised by c. Now after that, we can turn 4 to the power of 5t to 4 to the power of t raised by t. 4 to the power of 5 raised by t. Now our new equation is 7 times 4 to the power of 2 times 4 to the power of 5 raised by t. After simplifying that, 4 to the power of 2 is 16, and then 4 to the power of 5 is 1024 to the power of t. After that, we get times 7 times 16, which is 112, and then we leave the 1024 by the power of t by itself. And now our equation is 112 times 124 to the power of t, and that is equivalent to a times b to the power of t. Excuse me. Now, for our next formula, we have a times b to the power of t, and that turns in, and we're going to be changing that into a times b to the power of t divided by 10 minus 1. You're wondering, why would we ever do this? It looks a lot more scary. Well, as you get into higher math, or just in general, you're probably going to notice that you're seeing a lot less of a times b to the power of t, and that's because it is rewritten as a times b to the power of t divided by 10 minus 1. And this is just going to help you when instead of sitting there looking at your paper saying, I got the right answer. Probably didn't, just not in the right form. So for starting off, our equation is 5 times 3 to the power of t. Oh, let's go over properties we're using this. A to the power of b raised by c is the same thing as a to the power of b times c. And a to the power b times a to the power of c is the same thing as a to the power of b plus c. So now, first we're going to start off with 5 times 3 to the power of t. And we're going to be getting t divided by 10 first. So how do you do that? Pretty simple. You go ahead and just divide by 10. But it's not that simple, because you can't just make 10 appear out of nowhere. You have to make it so it's still an even equation. So we got to times it by 10 too, because 10 divided by 10 is 1. T times 1 is still t. So now we have 5 times 3 to the power of 10 times t divided by 10. Now we're going to use our property. A to the power of b raised by c, same thing as a to the power of b times c. Now we go ahead and have that. We have 3 to the power of 10, which once we simplify that is 59,049 to the power of t times divided by 10 times 5. Now, same thing, times the 10. How do we get the negative 1? Same thing, minus 1 plus 1. Those two cancel out to 0, so then you get 10 t divided by 10. Now, how do you get rid of that plus 1 now? Kind of the same thing we were talking about. A to the power of b times a to the power of c is equal to a to the power of b plus c. So we have 59,049 to the power of t divided by 10 minus 1 is practically the a to the power of b times 59,049 to the power of 1. That is equivalent to just 59,049. And our new equation could be, after rearranging and simplifying it, we have 59,049 times 5 times 59,049 to the power of t divided by 10 minus 1. After that, 59,049 times 5, that's equivalent to 295,245 times 59,049 t divided by 10 minus 1. Thank you, and this is how to simplify expositions with Drew lines. Exponential expressions with Drew lines. Thank you.